evening and welcome to Tinkering with Edkelar. This week I have something special from the retro computing corner. A very early graphics tablet, a Wacom PL-400. It features a built-in screen at 1024 by 768 pixels and originally came with a dedicated graphics card to drive it. The proprietary cable carries both LVDS screen and RS-232 pen input signals in one cable. Remember, this one came out shortly before USB became a thing at all, much less having the power to run a graphics display over it. However, since the graphics card kinda limited the usefulness of the device, Wacom later added a splitter box that took regular DFP, digital flat panel, as an input and provided either regular RS-232 or USB output for the pen feature. This device here isn't mine, it actually belongs to Karpour, who managed to hunt down both the tablet and the elusive splitter box alongside a matching pen. So all should work, right? Well, not so fast. DFP is a bit of an obscure standard that is hardly seen in the open, and to my knowledge, a similar technology to LVDS is most commonly used between a laptop motherboard and the internal display panel. It routes the signal digitally from one half of the case to the other by serializing the clock and color channels over differential lines. Low voltage differential signaling, LVDS. Both the LVDS and DFP are not entirely different from HDMI or DisplayPort. In fact, the 20-pin connector for the DFP input in the splitter box can easily be converted to take DVI, HDMI or DisplayPort inputs because the signals are identical. A passive converter does the trick. But alas, when Karpour tried to connect everything together, nothing happened. The device didn't show up in plug and play and no LEDs came on either. And he even used the required center negative 15-volt power adapter. So let's dig into it. First things first, let's check the splitter box and follow the power lines. Maybe a fuse is blown? Darn, does that thing really need 12 screws to hold the two half shells together? Okay, that looks integrated. Quite a lot of SMD components around two large ICs and some smaller silicone. No obvious fuse, but SMD parts can be stealthy. I'm digging in further to follow some traces. The first IC is a THC63 LVDM63A. What a mouthful! And that turns out to be an LVDS transmitter. It converts CMOS level input signals to differential ones. It is clearly the driver for the long display cable of the tablet. The second large IC is an SI I141 CT80, which decodes differential inputs into CMOS outputs. So clearly, this is the receiver for the flat panel input. The smaller chip, hiding underneath the serial cable, turns out to be a small I2C PROM. Smells a bit like the plug-and-play info. Up next, I'm checking the input socket. Nothing? Oh, that universal power brick needs a smaller inner diameter on the barrel jack connector. Now the power makes it in, but the large voltage regulator in the center still doesn't get any input. Now that is sus. Following the traces. Well, this part was mostly looking at the PCB, scratching my head and doing continuity checks. So I'll give you a summary. Here's what I found out. The supply line runs through a transistor before going to anything else at all. I didn't check if it's a FET or a bipolar transistor, but it clearly is a soft power switch. Now where does the control input come from? Turns out that the DFP socket provides that control input directly, besides a limiting resistor and a pull-down resistor. So that indicates that the input signal should be a positive DC voltage. And looking at the DFP port pinout, there is indeed a plus 5 volt line making it from the host to the display device. This is the only signal that can drive this power on transistor. Anything else is either a signal line or ground. And here's where things got weird. The standard defines pin 8 as plus 5 volts, which should connect to pin 14 on the DVI adapter. But it didn't. Aha! A clue! Is the adapter cable wrong? I checked. No, the cable has pin 8 and 14 connected. So there's an issue on the socket? It took a bit of poking and prodding, but I found out that the 5 volt signal pin inside the device is actually connected to pin 19 and not pin 8. Huh? Further investigation showed that the I2C prom should be connected to the plug and play lines, but those were off too. To confirm my suspicions, I tried to put plus 5 volts into the wrong pin on the splitter board, and indeed, there was a relay clicking in the tablet and the backlight came on. Now I'm sure. That socket, despite labeled as DFP, is not following the standard pinout. Maybe Wacom had a custom cable? To try out if the signals are at least working, I decided to desolder the socket and patch in a DVI cable directly. Checking out which wire leads to which pin. And fumbling the wires into the pins that carry the appropriate signal based on the PCB layout. The signal lines also had some wires crossed over. Only a handful of pins, mostly the shielding and not connected ones, were correct. And contact. Weird. It does show a pattern, but it is rather static. At the very least, it does seem to properly connect to the host now. And again, lots of poking ensued. And it seemed that both the clock and pixel signals leave the driver chip in the splitter box just fine. So, next stop. The tablet. Careful with the surface, it is just plastic and already has some minor scuff marks. And once I found the last screw, the back comes off without an issue. Oh, shielding. The first PCB seems to be the main controller board. There is a step-up transformer for the backlight and lots of identical ICs that lead to a bunch of flat flex cables, Those must be the tablet matrix drivers. The yellow wires connect to the screen panel through the next shield. And that is the actual LCD panel. And that one shield reveals the next one, including some small PCBs that seem to host the actual drivers for the LCD. Nothing looks sus here, but that one flat flex is a bit kinked over. Digging in deeper, turns out that the shielding we saw is part of the tablet matrix PCB. Now here's why that one flat flex is kinked over. The panel, including both driver PCBs, is a standard laptop display that you could buy stock back then. Wacom shoved the tablet PCB in between the panel and driver PCBs, so putting mechanical stress on all the connected flat flex cables. Yikes! But at least there is some hope. In case that the panel is faulty, there might be spares around. And again, many prodded pins later, I know the following. That narrow chip on the driver board is the LVDS decoder chip. It is directly connected via the yellow wires and the main cable to the splitter box. The signals make it there just fine. But nothing comes out of that chip. No signal at all. My scope is a bit too slow for the pixel data lines, but I should at least see some aliasing and not just a solid nothing. Now that would explain the lack of output from the panel. Ordering some spare parts. Now, how to desolder it? I took my hot air station for a first real spin. The Kapton tape is holding all the nearby components in place, just in case they heat up a bit too much. And exactly 2 seconds before the chip popped off, my camera ran out of memory. And after receiving both the spare transmitter, just in case, and a matching receiver, I realized that the receiver is not the one that goes with the transmitter. Putting out another order. Finally, the real chip arrived. Soldering the new chip in place was annoying to say the least. I used plenty of flux, but I don't have the thick stuff, only the pen style one. My best bet was the hot air station again. That almost worked, but checking continuity, it seems that at least all the pins are connected as they should, despite the chip being a bit at an angle. Testing the splitter box again with the new input decoder. And wouldn't you know, the panel still shows blocky images, but at least they are now moving. And woohoo! A part of the screen actually shows legible output. Now, since I don't know if the SMD soldering, the botched DFP connection or a broken panel is to blame, I started by making a proper repair to the DFP socket. I cut through all the traces that were wrong, that is almost all of them, and wired the pins to the appropriate points with some copper wire. Coincidentally, that wire fit into the PCB next to the socket pins. Also, the socket has a bit of a gap on the underside, probably for the solder to wick up, which is conveniently hiding that crime. Mostly. And what a better time to also reflow the off-kilter IC. Darn, that took way too long. But I made sure that every pin is connected and none are shorted. Assembling the screen again. If it doesn't work now, I don't see much hope anymore, so I might as well go for it. And now, a systems check. We got picture! And not even a single pixel is missing. Woohoo! Buttoning up the tablet case. Ah, whoops, I forgot. That brightness knob goes in first, not from the outside. And also closing the splitter box again. I couldn't get the tablet to work on my Linux machine. It seems that the serial tablets are no longer supported, or they require some special something or other. So to make sure that at least something is going on, I brought out my protocol analyzer. See, I said I had a project in the pipeline. Seems to be working. At least the tablet sends out lots of data when I move the pen around. I can't know if it's the right one, but I don't see why it wouldn't. It does react in tandem with the movements after all. So here we are, at Karpour's place. Let's have a peek over the artist's shoulder to see if it actually works or not. And that's it, an almost repair of the Wacom PL-400 tablet. It kicked my behind for some time, and it still has some kinks to iron out. It might be a driver issue, or it could be related to the serial to USB converter in the mix. I'll post an update if things change. This one took some time, because I only want to continue working on a project when I have reason to believe that progress can be made. And this one was a slow one, waiting on either ideas or parts. But then again, I'm doing this as a hobby, so I hope I'm forgiven when I pick my schedule for the fun factor to some extent too. I hope you enjoyed this episode. See you next time! Here's what I found out. The supply line. Darn it. I'm experiencing a supply line attack.